Welcome to the Tech Talk in ESSS series. And today we have with us Mr. Eric, who is the Director of Sales of Europe and India region from Greenhill Software. So welcome, Eric, to the 8th edition of ESSS. And it's a tremendous pleasure to have you. And you've been our partner from the first edition. So it's great to have you again and again on board with ESSS and supporting this initiative.
Thank you.
So, from our end, from the whole embedded community, my question to you and as a representative of Greenhill Software, it will be like, as safety and security are like a very concerning, ongoing concern. How do you foresee that these issues evolving over the next decade? You have seen it for a long time. Over the next decade, how do you see these issues?
Okay. Well, I don't have a crystal ball, but we can already make some predictions. And one of the predictions is certainly that the landscape for safety and security will evolve significantly in the next 10 years. And that's probably for two reasons. First, the technological enhancements that we observe every day and the ever greater interactivity between the systems. And that will have consequences. So we already some trends to react to these consequences, and we can make a few predictions. Okay. First of all, this increased complexity and this greater connectivity with system will certainly offer more surface of attack to systems. And that certainly will force the designers to put more robust security and safety measures into their systems. The second one is something we observed in the last years, which is artificial intelligence. And I think it could be a great asset in helping bringing more security into the systems. One reason would be it can certainly help detecting and addressing some threats by analyzing abnormal behavior or certain patterns that would be a sign of malicious activities. I see a third thing that's happening that we'll see the rise of quantum computers and quantum computing, and that's a threat to the basis of security, which is the cryptography. So one thing that I can foresee is us developing some new crypto algorithm that would probably be robust enough to resist an attack from quantum computers. More things I can foresee would be into probably the regulations and standards from the governing bodies and in the industry as well. Probably some more stringent standards and probably a mandatory compliance to the standards that will have the aim of forcing the designers to have more robust, more safer. Exactly. Other trends I can see, probably hardware can bring its contribution to more security. We already see that with the use in certain SoCs of what's called the trusted platform modules or the trust zone from ARM. Mm-hmm. So with the aims of creating some secured space, secure islands, enclaves where designers can store critical data, crypto keys, even do some critical computation protected from attacks by hardware. And I would imagine that this kind of hardware measure will become widespread. More things, maybe edge computing can come into the picture, having computation closer to the source, avoiding or reducing the surface of attack. So there's a lot of things. So it's a multifaceted approach to security that will make use of new technologies and then innovations to address this new challenge based on this ever-increasing interconnectivity between devices.
So it means the future seems challenging and interesting.
It's been always challenging. So, but the human brain and creativity is always there to find solutions. Okay. Thank you.
My second question would be like, what measures can be taken to ensure that hardware level security, is across different sectors is maintained there?
Okay, so that's an interesting question to ask a hardware question to a software guy, but let me try to address it. I think like in all systems, you need to have some ensure that you build on safe and secured foundations. So the first thing is to have a secure boot. Make sure that the firmware and the software you run on it is not altered by malicious activities. So to achieve that, you can use hardware things such as hardware-based crypto tools to sign the firmware you will use to bring up your system. So that's one measure. Another one, which is the foundation for the root of all secured system, is to establish a hardware root of trust. And that can be used with the use of technologies such as the one I was mentioning earlier in the previous questions on use of trust zone or trusted hardware platforms, places that create some secured enclaves where a designer can store its critical data and the keys, the critical keys. Third one probably is when your system is booting, you have a lot of data and that is at rest, that is in transit, and you need to ensure the criticality of this. Let me take you an example. Your system is running, there is a vulnerability that has been found, and you as a designer need to patch that vulnerability so that your system cannot be jeopardized. So suppose you do a over-the-air updates. You need to make sure that the patch you will put is not compromised. So again, you need to rely on signatures that could be brought by hardware crypto on the processors to do that. And maybe the last point would be, again, on how hardware can contribute to security is at the heart of security would be the random number generation. And those numbers cannot be predicted. So the unpredictability of these numbers is essential, and the hardware can really render some services there. So that's, for example, how hardware can help and bring in
security. Thank you.
Welcome.
Evolving.
Yeah, also good questions. I think we should keep the things that we're doing, but addressing this new perimeter. I think we still need to have a risk-based approach, analyze and assess the risk brought by these new technologies, and include them in our security analysis and mitigate those new risks that are brought by artificial intelligence. Second one is probably into the standards. We have very good standards, and we should keep them as a base, but also identify the new constraints brought by artificial intelligence and include them into the standards. And lastly, comes test and validation. Those are pretty complex code, and we don't necessarily master the outcome of artificial intelligence. So we need to validate and test the AI algorithms under a wide variety of scenarios and conditions to make sure that they are not bringing security concerns into a solution. So that could be done even by the use of, I can imagine, formal methods to mathematically prove that the algorithm used by the AI system is still respecting the safety and integrity of a system there. So that's some solution I can imagine. But you're right. This is an inevitable additions to our world that we need to cope with.
Yeah. So it will be interesting to see how we get adapted.
It's a fascinating, evolving world. I agree with you.
So thank you, Eric.
You're welcome.
Thank you for being part of EAAA once again.
It's my pleasure.
And thank you.
Thank you.